Greetings, loved ones. Let's take a journey.
Isn't that wonderful?
Yeah! Oh my God, that's hot!
It's spicy.
Okay.
That's hot.
But then you get the cool relish and sweet counterbalancing it, and then a little bit of the vinegar coming through. Excellent.
It's just perfect. Spicy hot sauce. Perfect bite every time.
So if you're gonna do it right.
That's what I want.
Hi guys, it's Roxy reporting live on the site of Diner, Drive-Ins, and Dives, and wow, I'm seeing a lot of physics. As you can see, guys munching on a juicy sandwich. We actually weighed the sandwich and it came out to be 3 pounds, or 1.361 kilograms. Man, that's grande, homies. From our measuring machine, we also found one bite to have a final velocity of 3 meters per second. Additionally, as he eats the sandwich, it's so spicy that the voltage is sparking his Guy Fieri tongue. Also, he's using a lot of power to eat the sandwich. Now let's get into the equation. First, we need to find Guy's acceleration using A equals VF minus VI over time. So plug in the final velocity of 3 meters per second and the initial velocity of 0 meters per second, and then the overall time for one bite, 1.84 seconds on the bottom. We get 1.63 meters per second squared. Next, use the equation F equals ma, or force equals mass times acceleration, and plug in the weight of the sandwich, 1.361 kilograms, and the acceleration of one bite, 1.63 meters per second squared. Your final answer will come out to be 2.22 newtons. Wow, that's really big. Welcome to Flavortown. Peace out.
You are Cookie Monster.
Oh my God! Oh jeez! Oh my God! Oh jeez!
Hey everyone, Sophia here, reporting about Kermit's big fall. As you can see in this video, Kermit has jumped off a building. He travels a full distance of 50 meters before hitting the ground. This is not a projectile momentum equation because of how he jumps straight down and not out, but it is a free fall equation. Free fall is when the force of gravity is the only thing acting on an object. Because it is only gravity, the acceleration is negative 10 meters per second squared. With all the data collected, we will be finding the initial velocity of his jump. The data that is given is that x initial is 0 meters, x final is negative 50 meters, v initial is what we are trying to find, v final is 40 meters per second, acceleration is negative 10 meters per second, and time is not needed. You're going to want to use kinetic equation number 3, which is v final squared equals v initial squared plus 2a times x final minus x initial. Simplify and solve to get v initial to be negative 24 meters per second.
Hey, this is Allie here, and I'm reporting on one aspect of physics in real life. Daily, there are forces exerting their efforts upon displacing objects and velocity that change an object's direction at any given time or second. In this video, there's the force of a car going at average speed that once a man slams on the brakes, the spoon stops so it's suspended in the air, while the inertia carries the woman forward, causing her to choke. The woman in the car applied in Newton's first law of motion, which is an object in motion will stay in motion, and an object in rest will stay in rest unless acted upon by an unbalanced force. The woman is experiencing the stopping of the car because she was traveling at the same speed as the car, but once it stopped, her body continued to be carried forward. The seatbelt acts as a brake of its own in order to decelerate the person's body from carrying forward. In this problem, there is a car going 16.67 meters per second velocity. I got this data by calculating meters per second from 60 kilometers per hour. If the object was at rest was accelerating, what is the force of the object? With velocity in mind, I researched the acceleration possible in order to stop a car quickly, and it was negative 20 meters per second squared. Then the average mass of a mid-sized car was 4,409 pounds or 2,000 kilograms. Using the equation F equals ma, you find the force and the known acceleration and mass, and multiplying 2,000 by negative 20, I got negative 40,000 newtons. In order to decelerate a car safely with this given momentum, applying the force, and still have Newton's law of inertia apply, this force is fairly accurate.
Ooh, look at that finger. Hey there, it's Sydney. In this segment, we'll be covering Salt Bay's sprinkling of salt. In this find, Salt Bay, a steak maker in Turkey, sprinkles salt on his delicious Ottoman steak. Because Salt Bay uses no force and zero initial velocity, but rather drops this salt, this seasoning is truly in free fall. In order to find the final velocity at which the salt falls on the Ottoman steak, we use the first kinematic equation. This covers motion in one dimension. After finding the time interval using t final minus t initial, we can plug in the values as well as the free fall given acceleration of negative 9.8 meters per second squared. Using all of this data, it is determined that particles of salt travel at negative 39.2 meters per second over the time period at which the steak is seasoned. Salt-based salt is super speedy.
A potato flew around my room before you came, excuse.
A potato flew around my room before you came. Excuse.
Hey guys, it's Gabbie. As seen in a potato flew around my room vine, the potato rotates in a uniform circular motion. When the tangential speed is constant, the motion is just like the potato flying in an orbital path put into motion by the fan. Tangential speed can be used to describe the speed of an object in circular motion. The tangential speed of the fan is the potato's speed along an imaginary line drawn tangent to the potato's circular path. Furthermore, acceleration depends on a change in the velocity. Because velocity is a vector, acceleration can be produced by a change in magnitude of the velocity, a change in the direction of the velocity, or both. The acceleration of the fan moving in a circular path and at constant speed is due to a change in direction. An acceleration of this nature is called a centripetal acceleration. In essence, the net force that is directed toward the center of an object's circular path is called centripetal force. A potato is flying at 56.6 meters per second in a circular path with the radius of 188.5 meters. The centripetal force needed to maintain the potato's circular motion is 1.89 times 10 to the 4th newtons. What is the potato's mass? First, you must use the equation Fc equals mv squared times t over r, and then convert it to m equals Fc times r over v squared times t. Next, you plug in the given variables and solve and simplify to get mass equals 1,110 kilograms.